Moving Bed Biofilm Reactor, or MBBR, technology offers a modern, efficient approach to treating industrial wastewater. This method tackles the challenging task of removing pollutants from industrial wastewater, ensuring that discharged water meets environmental regulations. Unlike traditional wastewater treatment methods, MBBR uses a unique combination of attached and suspended growth processes. This system relies on small, free-floating plastic carriers within the reactor tank. These carriers, with their large surface area, become home to a diverse community of microorganisms. These tiny organisms form a sticky layer called biofilm. The biofilm acts as a biological powerhouse, breaking down pollutants in the wastewater. MBBR systems are particularly effective in treating various industrial wastewaters, from food processing to pharmaceutical industries. Their flexibility and efficiency make them a preferred choice for industries aiming for sustainable and responsible wastewater management. At the heart of the MBBR process lies the biofilm, a living layer of microorganisms that coats the specially designed plastic carriers. These carriers, constantly in motion within the reactor, provide a vast surface area for biofilm attachment. The process begins when microorganisms naturally present in the wastewater begin to attach themselves to the carriers. These microorganisms, including bacteria and protozoa, secrete a sticky substance that helps them adhere to the carrier surface and to each other. As wastewater flows through the reactor, it brings in more nutrients and organic matter. The microorganisms in the biofilm consume these substances as food, leading to their growth and multiplication. This continuous growth ensures a thriving biofilm, ready to tackle incoming pollutants. Just like humans, the microorganisms in the MBBR system need oxygen to survive and perform their cleaning tasks. This is where aeration plays a crucial role. Aeration in MBBR involves introducing fine air bubbles into the reactor tank. These bubbles do two important things. First, they provide the necessary oxygen to the microorganisms in the biofilm, allowing them to breathe and break down pollutants efficiently. Second, the aeration system keeps the carriers moving within the reactor. This constant movement ensures that the biofilm is evenly exposed to wastewater and oxygen, maximizing its treatment capacity. Section 4: Degradation. Microorganisms at work. The real magic of MBBR truly happens within the biofilm, where a diverse community of microorganisms works, tirelessly to break down pollutants. These microorganisms, mainly bacteria, have enzymes that can break down complex organic pollutants into simpler, less harmful substances. One of the key parameters we use to measure water pollution is something called chemical oxygen demand, or CODE. CODE essentially represents the amount of oxygen required to chemically oxidize organic compounds in the water. Now, high CODE levels indicate a high concentration of organic pollutants, which, as you can imagine, can be pretty harmful to aquatic life. In the MBBR system, the microorganisms living in the biofilm utilize these organic pollutants as their food source. They break down these complex organic molecules, which effectively reduces the CODE of the wastewater. This process, known as biodegradation, transforms harmful pollutants into less harmful substances like carbon dioxide, water, and biomass. Section 5: Effluent separation, delivering cleaner water. After the microorganisms have done their job, the treated water, now significantly cleaner, needs to be separated from the biofilm carriers. This separation process is absolutely crucial to ensure that only treated water is discharged back into the environment or reused for industrial purposes. MBBR systems typically include a separate chamber or zone for effluent separation. As the treated water flows out of the reactor, it passes through a settling zone. The carriers, which are denser than water, settle to the bottom of this zone. This settling mechanism allows the clarified, treated water to be collected and discharged, while the carriers remain within the system to continue their treatment work. The separated treated water, now with significantly reduced cod and other pollutants, meets the required environmental standards for discharge or reuse. This clean water is truly a testament to the efficiency of the MBBR process and its role in promoting environmental sustainability. MBBR technology, with its efficient biofilm growth, aeration, degradation process, and effective effluent separation, presents a compelling solution for industries seeking to manage their wastewater responsibly and minimize their environmental footprint.